In this video on inverse functions, we're going to learn how to find a function's inverse function by working through each of the 4 examples you see on the screen here. So let's not waste any time and get started. The first function we have here is f of x, which equals to 3x minus 12. And to find its inverse function, we can follow 2 steps. The first step, step 1, is to swap the x and the y's in this function. Here's what I mean. I'll start by rewriting that function as y equals to 3x minus 12. And now I swap the x and the y's that I see. So this becomes x equals to 3y minus 12. And as such, that's the first step done. And so I move on to step 2. And in step 2, the idea is to rearrange this expression in such a way that we make y the subject. So let's see, if I quickly copy that result, we have x equals to 3y minus 12. And to make y the subject, I'll start by getting rid of this 12 that's being subtracted from the right-hand side, which I do by adding 12 to both sides of this equation. So we have x plus 12 on the left-hand side, which will equal to 3y on the right-hand side. Remember, we're trying to make y the subject, so we need to get rid of this 3 that's multiplying the y. And for that, we can divide both sides of this equation by 3. And of course, we divide the entire left-hand side by 3, so that it becomes x plus 12 over 3, which equals to 3y divided by 3, which is just y. And as such, we've now made y the subject. And in fact, we could copy that by writing y equals to x plus 12 over 3. And this is this function's inverse function. And so we could write our final answer as inverse f of x equals to x plus 12 over 3. And I'll go ahead and box that result. There we go. Now that that's done, I move on to the second function we have here. We have f of x, which equals to the square root of x minus 4 plus 1. Again, to find its inverse function, we can follow the same 2 steps. So step 1, remember? Starting from y equals to the square root of x minus 4, there we go, plus 1, all we have to do is swap the x and the y's that we see. So this becomes x equals to the square root of y minus 4 plus 1. And that's step 1 taken care of. We move on to step 2. And in step 2, remember, we need to rearrange this in such a way that we make y the subject. So let's go ahead. I'll start by copying this result. That's x equals to the square root of y minus 4 plus 1. And the first thing we can do here is get rid of this 1 that's being added to the right-hand side. And so for that, we go ahead and subtract 1 from both sides of this equation, which leads to x minus 1 equals to the square root of y minus 4. Now, to get rid of this square root, we're going to square the entire right-hand side. But since we're squaring the right-hand side, we have to square the left-hand side as well. And careful, when doing so, we don't square one term at a time. We square the entire left-hand side inside a pair of parentheses. So that this would look like, in parentheses, x minus 1 squared, which equals to the square root of y minus 4 squared, which leaves us with y minus 4. We're nearly there. We now get rid of the 4 that's being subtracted from the right-hand side. And we do so by adding 4 to both sides of this equation, so that we obtain x minus 1 squared plus 4 on the left-hand side, and that will equal to y. And we're done. We can copy this result as y equals to, in parentheses, x minus 1 squared plus 4. And thanks to that, we can define this function's inverse function as inverse f of x equals to x minus 1 in parentheses squared plus 4. And that's this function's inverse function. Now, of course, we could also expand this pair of parentheses here, for which we'd use our perfect squares formula. And if you're not sure of what I mean there, let me remind you that if you have a minus b squared, well, that's equal to a squared minus 2 times ab plus b squared. And so using this result for x minus 1 squared, this quickly becomes x squared minus 2x plus 1 plus the 4 that we have at the end there. Finally, gathering this 1 and this 4, we could also write this function's inverse function as inverse f of x equals to x squared minus 2x plus 5. And that's the final answer. Okay, let me just erase this perfect square formula here. There we go. And we move on to the third function we have here, f of x, which equals to 4 over 5x. Well, once more, we follow our two-step method. So step 1, starting from y equals to 4 over 5x, we swap the x and the y. So this becomes x equals to 4 over 5y. And that's step 1 done. We move on to step 2. And in step 2, remember, our goal is to rearrange this to make y the subject. So let's see how to do that. Starting from x equals to 4 over 5y, what we notice here is that the y we're after is on this denominator. And so to get it away from there, what we can do is multiply both sides of this equation by this denominator. In other words, we can multiply both sides by 5y. So that's times 5y on the right-hand side and times 5y on the left-hand side. Doing so leads to x times 5y on the left-hand side, which is the same thing as 5xy. And on the right-hand side, we'll have 4 divided by 5y times 5y. And since those two operations cancel each other out, we're just left with 4. We're nearly there. On the left-hand side here, we can see that y is being multiplied by 5x. So to get rid of that 5x, we're going to divide the left-hand side by 5x. And as always, since we're doing this on the left-hand side, we need to do it on the right-hand side as well. So we divide the right-hand side by 5x as well. And so we get 5xy divided by 5x on the left-hand side, which just leaves us with y. And that y is equal to 4 divided by 5x, which is 4 over 5x. And we're done. We can now define this function's inverse function as inverse f of x equals to 4 over 5x. And that's the answer. We move on to the fourth and final example for this video, in which f of x equals to 5 over 3x plus 2. Well, by now it should come as no surprise we follow the same two steps. So step 1, we start from y equals to 5 over 3x plus 2, and we swap the x and the y's that we have. So this becomes x equals to 5 over 3y plus 2. And that's step 1 taken care of. So we move on to step 2, and in step 2, we rearrange this expression to make y the subject. So starting from that previous result, x equals to 5 over 3y plus 2, just as in the previous example, we notice that the y that we're after is on this denominator. And so to get it away from there, we can multiply both sides of this equation by this denominator, 3y plus 2. In other words, we'll multiply the right-hand side by 3y plus 2, and we'll multiply the right-hand side by 3y plus 2 as well. Now, when doing this, because there's an addition between 3y and 2, you need to make sure to write this inside a pair of parentheses, so that on the left-hand side we have x times, in parentheses, 3y plus 2, and that will equal to 5 divided by 3y plus 2 times 3y plus 2. But those two operations cancel each other out, and so we're just left with 5 on the right-hand side. Our next step is to distribute this x across this pair of parentheses, which leads to x times 3y, which is the same thing as 3xy, plus x times 2, which is 2x, and that's still equal to 5. Remember, we're trying to isolate the y that we see here, and so our next step could be to get rid of this 2x, which is being added to the left-hand side. And so for that, I'll subtract 2x from the left-hand side, and I'll therefore subtract 2x from the right-hand side as well. So this becomes 3xy equals to 5 minus 2x. Finally, on the left-hand side, we notice that y is being multiplied by 3x. So to get rid of the 3x, we'll divide the left-hand side by 3x, and we therefore do the same on the right-hand side. So this becomes y equals to 5 minus 2x over 3x. And as such, we're done. We've now made y the subject, and we can define this function's inverse function, inverse f of x, equals to 5 minus 2x over 3x. And that's the final answer. And there we go. Hopefully you now have a slightly better idea of how to find a function's inverse function following these 2 steps. And that's it for this tutorial.